Okay, let's look at iron carbon phase diagram. We know that the phase diagram is in the box form where y axis is the temperature and x axis is a carbon weight percentage. So one end is iron, its weight percentage is 0, and other end is Fe3C. So its weight percentage is 6.67. Sometimes the iron carbon phase diagram is also we can consider it as a iron carbide diagram. That means Fe3C diagram. So there are three invariant reactions in this diagram. So generally those are represented by three horizontal lines. Okay, so the invariant reaction which happens at 1493 degrees Celsius. So here 1535 degrees Celsius is melting point of iron. Then 1410 is a solid state transformation, and at 910 degrees Celsius is another solid state transformation. So we will talk in detail about it later. So let me first complete this invariant reaction. So there is a phase boundary like this. Then it connects with 1410. The another invariant reaction runs here, and their phase boundaries connecting these two invariant reactions. So this is 2.1 weight percentage of carbon, and this is 4.3 weight percentage of carbon. Here this is 0.1 weight percentage of carbon, and this is 0.2, and this is 0.5. So the horizontal temperature is how much? 1493 degrees Celsius. Okay, and the next invariant reaction is at 1150 degrees Celsius. So another invariant reaction is at 725. So which has another horizontal line running here. So its end compositions are very close to the pure iron, so of about 0.02 percentage. So this is 0.8, and next it goes up to 6.67. So now connect here, connect these boundaries like this. Okay, so this is the phase diagram. Understood? So now let's write down the phases. Okay, so this large temperature region, this large region of temperature region is a liquid region, and this small triangle is a delta. So we can name it as a delta ferrite. Then this is a large single phase region, so we can call it as a gamma. So gamma means it is austenite. So the one who made this diagram is a Robert Austin. Okay, his name is Robert Austin. On behalf of his identification, we can consider this region as a austenite. Large single region is a austenite. So then again there is a small triangular region. So this is called a alpha. So its name is simply a ferrite. And there is a vertical line itself is a phase. So it is a single phase region. So the name we can call it as a Fe3C is a cementite. And now the single phase regions we made. So two phase regions we need to label. So this is gamma plus liquid, and this is liquid plus Fe3C, and this is gamma plus Fe3C, and this is alpha plus gamma, and this is alpha plus Fe3C. Okay, so here it is a delta plus liquid, and finally this is delta plus gamma. Okay, so each invariant reaction gives some special name, so we need to observe this. So the one which happens at 1493 degrees Celsius is a peritectic reaction. Okay, peritectic. So the one happening at 1150 degrees Celsius is a eutectic reaction. Okay, and the one which happens at 725 degrees Celsius is eutectoid. Okay, eutectoid reaction. Okay, so let's write down these invariant reactions. Firstly, at peritectic reaction. So in this reaction, you can see a delta plus liquid, so which transform to on cooling at 1493 degrees Celsius into a single phase gamma. So the composition of delta is 0.1. So here a liquid is 0.5, and here gamma composition is 0.2. So this is called a peritectic reaction. So similarly, next we need to consider that eutectic reaction. So here the liquid which transforms to two phases. So on cooling of about 1150 degrees Celsius, which transforms to gamma plus Fe3C. Okay, so here liquid percentage is 4.3, and gamma is 2.1, and Fe3C is 6.67. Okay, so this is nothing but a eutectic reaction. And at last reaction, invariant reaction, is eutectoid. So here the single phase, that means the gamma, which is a composition of about 0.8, which is decomposes on the cooling at 725 degrees Celsius, and which transforms to alpha and Fe3C. Okay, so here gamma is 0.8 and alpha is 0.02, and Fe3C is obviously 6.67. Okay, so this is the iron carbon diagram. So one more thing here, so in this diagram there are two alloys are there. So what are those alloys means steels and cast irons are also there in this diagram. So the alloys which are less than 2.1 weight percentage are called as steels. So those alloys are steels less than 2.1 weight percentage. Suppose if the alloys with more than 2.1 percentage are cast irons. Okay, so this is the complete explanation about the iron cementite diagram or iron carbon diagram. Okay, so I hope you clearly understood about this concept. Prepare well. Okay, so see you on next lecture.